Okay, so I'm hopping right into the topic on velocity here. And it actually begins with a practice question on displacement and distance. And so if we wanted to, why don't you guys try this question? Now that I've kind of given you a little bit of background on some vocabulary words, why don't you try this? You have a person, he walks east for a while, then he turns around and walks west. Try to tell me the displacement and the distance. The calculations are pretty easy. You're just adding and subtracting numbers. So I'll even write out the two things here. A distance is d, and the displacement is d with like a little arrowhead on top. If you want to find your distance, the one I'm going to do in red there, what do I need to do with these two numbers? I just add them up. So this one is 16.7 meters added to 39.0283 meters. So if you add those two numbers to each other, here's what I got. I got a grand total of 55.7283 meters. And that's actually not going to be considered correct. We need to talk about why. According to this value right here, we believe that we are accurate and that we know this digit for sure is 5, and this digit for sure is 5, and this digit for sure is 7. And I'd agree with all of that, but I don't know that for sure this digit here is 2. And here's the reason why I don't know for sure. The top number of 16.7, I was able to measure the tens, I was able to measure the ones and the tenths. But the next digit, I don't know what that digit was. I didn't have the ability to measure it. But like, is there another digit? Yeah, we didn't possess the skills to measure it. Let's say that this number was actually 16.71. But we weren't able to measure the 1, which is why we stopped at 7. Well, this 1 and this 2 would then add together to make this not 2, but 3. So I am not confident this number right here is a 2. I don't know that for sure. And then let's say the next digit after that was a 5. Again, this number right here, I wasn't able to measure those digits, but if I was able to, there is another digit that comes afterwards. Well, this 5 and this 8, they would have rounded to like make this next number be like even bigger. And so I'm not confident in that number here either. So when you add numbers together, you basically got to cut it off where your last digit was. So since this only went to 16.7, the final answer here is going to be 55.7 meters. So I'll write that out kind of nicer here. I know, to the best of my measuring ability, that it went 55.7 meters. It probably went 55.73243, but I don't know the next numbers for sure. And so I don't want to write them down unless I know them for sure. Now for displacement, which way did he walk more, of east or west? Well, west, right? Right. So since in this example right here, I need to have a direction of west, I just need to know which one was more. So rather than adding these, we'll subtract them. So if you took your 39.0283 meters and you subtracted 16.7 meters, the same logic's going to apply. When I'm done, I need to make sure that I round this appropriately. So 39.0283 minus 16.7. My calculator gives me this value here, 22.3283. I guess that'd be meters. But I need to round at some point. And the question is, how confident am I in the values that are there? I feel pretty confident this first number is a 2 because I had 3 and I subtracted 1. I knew those numbers for sure. And 9 and 6 subtracting and 0 and 7 subtracting, I knew those for sure. But these digits right here, the 2, the 8, and the 3, I don't know what numbers would have been here if I had a good enough measuring tool to measure them. And so I'm really not confident in this number at all, because there could have been like a digit here it could subtract it from. And same thing with this one, and same thing with this one. So because this thing right here had 3 digits, I have to cut this number off at 3 digits as well. So then the second answer for displacement, he told it a grand total, a net distance of 22.3 meters to the west. Two different numbers though, hey? Depending on whether we add and subtract. Hey, come on in. Okay, so assuming, and again, like I've been saying all class here, if that didn't make sense after, one example's worth, that's fine. Okay, don't freak out if we need more examples. I will work with you guys more in small groups. But my goal in this next section here is now to upgrade and talk about something called a velocity. So it's very, very similar in terms of where we're going to begin. The first thing we have to discuss is the vocabulary. One of these terms, we care about direction, and then the other term, we don't care which way we travel. So I put on the slide here, the velocity and speed, we often misuse them. When you guys talk about like how fast you were traveling, speed just talks about the number. Like if I said my speed was 100 kilometers an hour, that's correct. But if I said that I traveled 100 kilometers an hour west, see how that adds more information? And so the same sort of principles apply. Speed just gives you just the number. Velocity adds the direction. So the letters we're going to use are kind of similar. If I give you just a V, V is your speed. But if I give you V with a little line over top of it, that's now your velocity. And the same sort of concepts are going to apply here as we try some new examples. So that's actually what I have written on this slide here, I guess. Speed is how far you travel per time, and velocity is how far you travel, but we care about a direction. So here's actually one of our first formulas. Here's a formula we can use to calculate a velocity or a speed. If you ever want to calculate a speed or velocity, what you have to do is you have to figure out how far you traveled, and you have to divide it by how long it takes. If you can do those two things, that tells you your speed. Right? For example, if I was driving, I used to drive to Fort Macleod every day, so I'd use this as an example. To get to Fort Macleod, I drove 50 kilometers in about 30 minutes. So if I take 50 and I divide by half an hour, then that tells me my rate of speed. Right? You take the two numbers and you divide them by each other. So it's a pretty easy process. But we have to make sure that we get all the little details right I've been focusing on as we go along. So let's try this example here. Really like low level difficulty, hopefully, to start. There's a person that walks 10.0 meters away from a stop sign, and they did this in 5 seconds. What was their speed? How fast are they traveling if they can go 10 meters in 5 seconds? Well, here's how we'd use that formula then. The change in your speed, was it actually change in speed? No, it was just speed. I take back. The formula on the previous slide was V with a little arrow is equal to the change in your distance over the change in your time. That was the formula we were given. Ah, good call. Now you said displacement though, right? That's okay. Since I asked for speed though, speed we don't care about direction. So what I wanted to point out here is that if I don't care about the direction on this thing right here, I don't care about the direction on this one right here either. So if you're going to start removing those little arrows for direction, remove them both. So I actually do not, I care about my distance here rather than my displacement. So how far did you travel? 10 meters. Do I know which way they traveled? I guess away from the stop sign. I don't even know whether it was north, south, east, or west, but I know how far they went, and I know how long it took. It took 5 seconds. Now, here's where some of you would make a mistake, and so I really want to try to clarify right now that the answer is not 2. What is 10 divided by 5? It's 2, but we have to use our significant digits properly. Okay? This was measured with 3 digits worth. This one, and then the numbers after it give us 3 digits right here. And this 5 right here gave us 3 digits afterwards as well. And so I have to maintain a little bit more precision. I know that it's more than just 2. It's actually 2.00 meters per second. Although my calculator rounds it to the number 2, I get to keep a few more digits, and so it was exactly 2, right on the dot. I get to keep 2 more digits worth here. So this had 3 digits, this had 3 digits, this number here better had 3 digits as well. So be careful when you use your calculator, because if you type in your calculator 10.0 divide by 5.00, your calculator will tell you that it's 2. But we get to keep a couple extra zeros afterwards because of those digits rules. Again, the more we do this, the more it'll make sense. I really don't think that the best learning we're going to do is today. I need to give you some tasks to work on. That'll help solidify this. Okay, there's a long blurb here for another example, so you have to bear with me as we kind of read through this. Say we have 2 trainers with stopwatches, and they get timed with their stopwatches. So the first guy, here's the starting point, and there's someone here with a stopwatch, and this person here is 12 meters south away. And then a second person from the starting point is 65 meters south. And then a third person starts running. So a third person starts running here. And basically the way this works is as soon as this person right here sees them run past them, they hit their stopwatch. And as soon as they ran past this person, they hit their stopwatch as well. And so we know how long it took. It took 1.6 seconds to run this distance. And then to get to this person right here, it took 8.7 seconds. The question I've got then is, what's the velocity? You guys paying attention? Okay. So I'm going to need a new slide to kind of illustrate this, but I need to use that formula on the previous slide. It was to find a v, you need a delta d divided by a delta t. And in this example here, because I asked you for a velocity, we care about the directions. So we need to know which way things travel. So in order to find the velocity, I need to be able to figure out, well, how far did you actually travel? Now, I actually have 2 numbers here. I had 12 and I had 665. You know what? I'm actually not going to be using either of those numbers, because what I'm really looking for is, well, from this point to this point right here, during this time interval, how far did the person actually move? The answer is 53 meters. Because from here to here was 12, from here to here was 65. How far is it from timer 1 to timer 2? Well, it's 65 minus 12. Does that make sense? So like from when he started right here to when he finished right here, there was 53 meters that was actually traveled, because 65 minus 12 is 53. So even though 53 is not one of the numbers that was actually given, that's how far was traveled, 53 meters south. The second question is, how long did it take for the person to run those 53 meters? Well, same logic. I'll use another color, though. It took 1.65 seconds to get to here, or sorry, 1.6 seconds to get to here, 8.7 seconds to get to here. That means that during this time frame that we care about, what is that going to be? 7.1? Yeah, there we go. It took 7.1 seconds to go from here to here. So I've got to subtract these 2 numbers right here to calculate how long it actually took from position 1 to position 2. So that's where this little delta comes in. Those little triangles are the changes you have. So it took 7.1 seconds. So now let's divide. What is 53 divided by 7.1? Well, I got this number here. I got 1.4, no, not 1.4, 7.4, and I bet you my calculator would keep going if I was allowed to. This is the classic example of why we care about those significant digits. Because, like, we need to round this at some point here. So what is fair for rounding? This number up here has 2 digits. This number down here also has 2 digits. So when I'm done, I want to round to 2 digits. So I'll start erasing all you guys. Okay, this now has 3 digits. But like 7.4, 4 would need to round up, right? Because 6 is more than halfway there. So the right answer would be 7.5 meters per second. And we care about a direction, so we would say south. And this is how we would properly answer this. We would have to include proper rounding. We need to include a proper set of units. And we have to include a direction. And all of these parts are really necessary in physics. Okay, I'm really going to try to hammer into you guys getting the little details right at first, because I want you to build healthy habits. Some people would just tell me the answer is 7.46. That's not correct, because you didn't tell me which way you traveled. You didn't tell me what units. Like, is this meters per second? Is it kilometers per hour? Like, without a unit, it's no good. And it needs to be rounded properly. Did anybody have any questions about that example? At least that you can think of right now? Again, I'm starting to build some skills here, so I don't expect you to like fully understand everything yet. It's not until I give you some tasks that we can work on that this will make more sense, but at least for now you're able to follow. Or it's Monday morning and you don't really care yet. Okay. I have one last example, then we're kind of done for the day. Sometimes what we can do is we can actually rearrange formulas and work backwards. Here I'm going to tell you that a toy car travels 15 meters per second. That was a speed. And I'm also going to tell you that it traveled for 16.8 seconds. What we've been asked to solve for now is a displacement. And this is where you need to have some pretty good math skills. Let me try to explain why. The formula that I've given you, the only formula we've really learned so far is this. V equals delta D over delta T. And since it asked for displacement, I then care about direction, so I will include the little arrow hats. Here's the problem though. Last time I took D and I divided by T. But if I'm looking at the values that I was given a speed, I was given a time. It means it looks something more like this. I know that my speed was 15 meters per second, and it actually says I was going east, so I actually know which way I was traveling. I know this number right here. More than that, I also know how long it took. I know it took 16.8 seconds. But what I don't know is the delta D. In a way, this is kind of like an algebra problem. We need to isolate for this D right here. It's kind of like in math if I gave you this. 3 equals x over 2. This is kind of what it's like. If I gave you a math problem and said this, could you solve for x? The answer in this example here would be 6, because you would times both sides by 2, and 3 times 2 then would give you 6. That's kind of what we need to do here. So if you kind of understand your algebra concepts, I'm going to multiply both sides here by 16.8 seconds. And what that should do is that should cancel this bit right here. If that part there, if I lost you there, can you let me know another time? I want to explain some of the algebra rules here, but I times both sides by 16.8. And what happens now is the 16.8 is now kind of up on this side over here. Now, watch this. This was measured in seconds. This second here can cancel that second here. And now what I have to do is take 16.8 and times by 15. So if I do that, 16.8 times by 15, I get this answer here, 252. The unit is m. That's good, because isn't displacement measured in, like, say, meters? Isn't that how far you'd travel is meters? And I still have a direction. I would have traveled east. That would be my change in displacement. And I kind of had to use some algebra skills to, like, rearrange this formula. Okay. I'm going to show you another way of doing this in a second, but hopefully that made a little bit of sense. This actually would be incorrect. There's actually a mistake here still, though. And it has to do with my rounding. I know that when I typed these two numbers in my calculator to multiply, my calculator spits out 252, and you think, hey, that's a nice round number. The problem is what I was able to measure to. This number here was measured with 2 digits, and this number here was measured with 3 digits. And according to the rules that we've kind of set for rounding, I'm only allowed to keep 2 digits. And this shows 3. Now, there's a couple ways I could try to solve this. I could just say, well, let's round it to 250. But the problem there is that I'm not sure what that's rounded to. Is that now rounded to the nearest ones or the nearest tens? That's ambiguous. So here's how we'd actually write it. we write it as 2.5 times 10 to the 2 meters east. What we're going to do is we're going to move it into scientific notation by moving the decimal place over twice. And by doing that, now I keep 2 digits only. The 2 and the 5 I'm going to keep. This 2 I was able to round off, but like without it looking a little ambiguous, now this for sure has only 2 significant digits. 2.5 times 10 to the 2 meters east. This would be how we'd write our final answer. Maddie. Good point. Okay. The reason why is that this digit right here, though, I was only given 2 numbers worth of like knowledge as to what I know about my value. This 15 meters per second, it had been rounded. It might have been 15.43275. Like there are more digits, and that was as good as I can measure it. Does that make sense? Now, this one right here, I was able to measure with 3 digits worth. And so the rules that we've kind of applied, I know that in this bit right here, I'm writing more than I normally would. But like, can I go back to a previous example like this one here? When I took 53 and I divided by 7.1, I actually got 4.6, and like it just kept going for forever. And in this example here, it made sense that I had to round at some point, right? The rules that we've set out in physics for how to round, we want to be consistent with them. So if this has 2 digits and this has 2 digits, we want to keep this with 2 digits. Even though maybe it didn't seem necessary on this example, we want to use the same rules. So the same rules still apply. This had 2 digits. This had 3 digits. We want to keep our final answer with the least number of digits. So we want to only keep this one with 2. So yes, I agree. This was actually a little bit more work to write out, but we need to be consistent, if that makes sense. Okay. I'm going to stop now. This is not something that I expect you guys to like instantly get, okay? If it was, we wouldn't devote a third of our time to it, okay? So please don't freak out right now if you're going, Chris, I'm a little lost today. It's normal, okay? I think that me explaining stuff to the whole group is kind of a necessary evil. Here's what I want you to do though, because some of you are starting to pack up. I don't actually want you to quit yet. I've got some practice exercises at the end of this example here. I'd really like for you guys to try some of these. Okay. Tomorrow I have a work day scheduled. Now, I don't really assign like homework. This is not due. There's no mark assigned to this. But what I'd really like you to do is I'd like you to try these 6 examples and see whether you know what you're doing here based on the hour or so that I've talked today. If after 1 hour of me talking at you, this makes sense, that's great. But I think you need to try it. We need to apply it. We need to get you guys some feedback. Okay. So tomorrow, if you guys can you have tried some of these practice examples? And then I'm going to give you guys some time more tomorrow to work on this. And guys, give me a second to finish here, okay? I know I'm kind of done with like the main part, but I'm still talking. Okay. Tomorrow, I'd really like to spend some time chatting with you guys in small groups or one-on-one, where if you have some questions, I can try to answer them. Because kind of like with that bowling analogy, I'm trying to talk to all of you right now, and this is not the most effective way to teach someone how to do something sometimes. Okay. So that's my plan for tomorrow, to give you guys some work time to practice and to ask me some questions. Does that sound good? Okay, so you do have a few minutes left today. Like, class isn't quite done yet. You have a little bit of time to work on that. You can even start asking me questions now. Okay. But I'm going to leave that up to you. You guys make the call as to what to do next. Okay. I guess one last reminder, and then you guys can take off if you want. Don't forget, if you want to redo anything from the chemistry unit, you're welcome to. Okay. Just like it's like a first draft or it's your first attempt at something. If a lab or an activity wasn't to your liking, you can improve on it. I really believe that's the way we should make school. We shouldn't make it so like you write a test and well, there it is, that's your mark. If you can show me that you can improve on it, I really believe in this growth stuff. So, okay, that's all I got. You guys have 5 minutes, I guess. So I'll talk to you guys in smaller groups now.